Okay, another Algebra 1 problem, again Chapter 3, Section 9. Now we have a situation where we've got two cars traveling at each other, and we've got to figure out about when they'll meet or when they're so far apart from each other. Let's read through the situation here. Under ideal conditions, a siren can be heard from up to 440 feet. However, under normal conditions, a siren can be heard from only 125 feet. In this case, a car and an emergency vehicle are headed towards each other. The car is traveling at a speed of 30 miles per hour. Okay, so we've got the car is traveling at 30 miles per hour, or about 44 feet per second. And since we've got feet up here, we probably are doing the feet per second, so let me just do the feet per second ones. Okay, and then an emergency vehicle is traveling at a speed of 50 miles per hour, and it's going at 74 feet per second, and that's our emergency vehicle. Okay. If the vehicles are 1,000 feet apart, okay, we're 1,000 feet apart, and the conditions are ideal, okay, so under ideal conditions, so that's this one up here. So I don't need the 125, I just need the 440, sorry. Right, that's ideal conditions, 440. And how many seconds will the driver of the first car hear the siren? Okay, so let's go back through that again. I'm looking for how many seconds will the driver of the first car hear the siren? There's my question. And I know that my distance is equal to my rate times time, so I've got my rate column, my time column, my car row, and my emergency vehicle row. And anytime I do a distance, rate, time problem, a uniform motion problem, I always set up a table to organize my thinking. For this case, I've got a lot going on here, so I'm going to add to my little graphic here of my emergency vehicle and my little car. So I know that they are originally 1,000 feet apart. Okay, so the distance from here to here, that is 1,000 feet. And I know that I'm under ideal conditions, so I know they can hear this, the car here can hear this siren over here at 440 feet. So somewhere in between when they are 440 feet, oh, I could do that in purple. Somewhere in here they are going to be 440 feet apart is when the car will hear that siren. And I want to know how many seconds that's going to take for these cars from when the siren gets turned on until the car can actually hear it. So I'm looking for the seconds it's going to take this car to travel this distance here. So let's read some more stuff. The car is traveling at a speed of 30 miles an hour. Okay, the car is traveling at a rate of 30 miles per hour. But we are doing we're doing feet per second though. Sorry, let's go back here. So let me put that back. And we are doing 44 feet per second. Car is traveling 44 feet per second. And the emergency vehicle is traveling 74 feet per second. Get my units right on here now. So that was feet per second, and the car was traveling at 44 feet per second. Okay, the time, we don't know the time, but they're both going to be traveling the same amount of time till they're that far apart. So our time can stay t. We don't know time. And our distance. Well, we know distance is equal to rate times time, so this is going to be 44t, and this one's going to be 74t. Okay, so let's analyze this a little bit further. We want to know when we're only 440 feet apart. We know we're 1,000 feet apart, so we need to know how far they can actually travel. So how far this distance over here and this distance over here is going to add up to be. Well, if I take 1,000 and I subtract, take the 1,000, and I subtract the 440, that should give me the amount of distance the ambulance and the car should be allowed to travel together. And when I subtract those two, I end up with 560. So the total distance of the ambulance and the car is allowed to be 560 feet. So then I can add that up. So the total distance is going to be 560. Well, how far did the car travel? Well, the car traveled 44 t. We don't really know, but we know it's 44 t. And how far did the emergency vehicle travel? Well, that's at 74 t. And now we've got an equation with one variable, and it's fairly easy to solve it. So we just combine our like terms, so 44t and 74t should be 118t. It's going to be equal to 560. And then the next step, you would divide both sides by the 118, divide by 118. And when you do that, you should end up with t being approximately, remember the equal sign with the squiggly lines means approximately, and you grab your calculator and divide, and you get 4.75. Well, what does that tell us? 4.75 what? Well, we are being asked to find t, which is time, and time, well, this is feet per second, right? So this would be in seconds up here. So our answer would be at approximately 4.75 seconds.